Hello everyone, welcome back to VLSI Simplified. So this video is the ModelSim demo continuation of our previous lesson on Verilog net data types. So if you haven't watched the previous video yet, I highly recommend checking that out first. That's where we explain all the Verilog net data types in detail, like wire, wire OR, wire and Trireg. So in this video, we will simulate those examples and see how each one behaves in action and how they resolve conflicting values in a ModelSim. So let's fire up ModelSim. Alright, this is VLSI Simplified. Let's get started and let's simplify.
Like a Hellcat.
Here I have a net data types like wire, wire OR and wire AND. And in the assignment block, I have assigned wire equal to driver A as well as driver B. So same applies for wire OR and wire AND. So each net data type will be assigned to two drivers at the same time. So in the stimulus block, I have a display statement. After that, I'm driving some of the possible values to the driver A as well as driver B of each net data type. So here I am driving 0, 1 for drivers of wire as well as drivers of wire OR and drivers of wire AND. Next I am driving 1, 1 and 1, 0, 0, 0, then high Z and 0 and both high Z's and unknown versus 1. So let's jump into a simulation. Let's compile them all. Compile successful. Then we'll start simulation. So here we can group these signals. So you see grouping. So it is wire. So let's run it. So here we can see first I am driving values 0, 1 to wire, wire OR and wire AND. So because of these conflicting values, the wire output is unknown. But in wire OR, so any one of the input is 1, so the output will be 1. So the output is 1. In wire AND, all the input should be 1, then only the output will be 1, else it is 0. Next 1, 1, these are the values. Then 1, 0, which is similar to 0, 1. Then both zeros, so there is no conflicting values, all the outputs are 0. Then coming to high Z, so one input is high Z, another one is 0, so wire and wire OR and wire AND, all the outputs are 0. When all the drivers are high Z, obviously the output will be high Z. When coming to unknown, this is the value 1. Due to the conflicting values, wire output is unknown. In wire OR, it is 1. In wire AND, unknown. So here you can see how these net data types resolves the conflicting values in the simulation. So here is the clear table. So these are the driver values and these are the output values. So from this we can conclude that wire, for any conflicting values, it drives value unknown. Like 0, 1, its value output is unknown. And for 1 and 0, the output is unknown. As well as unknown, this is 1. These are also conflicting values, so the value is unknown. So coming to wired OR, so 0, 1, both are conflicting values. Using OR, the output will be 1. Same for 1 and 0, the value is 1. For unknown and 1, the output is 1. And coming to wire AND, it resolves using AND gate. So conflicting values 0 1, the value is 0, 1 0 0. So unknown versus 1, the value is unknown. So this is how the net data types like wire, wire OR and wire AND resolves the conflicting values in the simulation environment. Next, we will jump into Trireg. So in this example, I have a module and a driver, driver A and driver B. And the Trireg variable name is bus. So in the assignment block, so I am assigning the driver A and driver B to a bus using a assign statement. I have some display statements. After that, I am driving a value 1 to a driver A and high Z to driver B. After that, I am releasing all the drivers. The releasing in the sense I am assigning a value high Z. So it means like no 1 or 0 is assigned or derived. After that, I am driving high Z to a driver A and 0 to driver B. After that, I am releasing again. All the drivers will be released and the high Z will be assigned. After that, I am assigning unknown to a driver A and high Z to driver B. After that, I am releasing all. In the simulation environment, we can see how the Trireg behaves. So, as I told you before, so driver A equal to 1 and then driver B high Z. So here I am assigning a value. After that, I am releasing a value. Releasing in the sense both drivers will have a high Z. But the output, that is bus, it's still 1. The value is still maintained. Usually in wire data type, the value will be high Z here. But this Trireg holds the previous value, that is 1. It still holds until it's getting updated with a value 0. So here I am driving a value 0 and high Z. So here the value continues to be 0. A Trireg net behaves like a bus hole circuit. It remembers the last logic level, that is the 1 here and 0 here and unknown here. So this is purely simulation modeling and is not synthesizable in typical ASIC or FPGA flow. So in our next video, we will discuss about Verilog variables. Until then, stay tuned and subscribe to our channel so you don't miss our upcoming videos. See you in the next video. Bye.